All right, for part A, we want to write this choose random pivot method, which is basically going to choose a random index location within our linked list that's going to represent the location of our pivot, okay? So first we need to do something with size. Why do we need to do something with size? Well, it's because it's a linked list, right? With an array, we're able to just call dot length and see how many elements we have total and then just half it, right? Whereas given that it's sorted, but with a linked list, we don't have a way of calling any length method. And so we need to actually go through the entire linked list by incrementing the size and then use math.random to get the random index. So this is just going to be a straightforward for loop. So ll node temp equals node, and then as long as temp is not equal to null, as long as we're not at the end of our linked list or overreached, temp is going to equal temp.next. And then we're going to increment size at every iteration. Okay, so now that now that we know how many total elements we have in our linked list, how can we use math.random? Well, math.random is going to return to us a double, okay? And it's a double between 0 and 1. 1 is exclusive, which means that if you multiply math.random by size, it's going to give us some number that is between 0 and size. That's exactly what we want, right? And how do we make sure that this fits the type of index? Index is of type int, but math.random is going to return to us a type double, right? So we have to make sure that we cast it to int. And in this case, it's okay because it's a small enough number that we're not going to be losing a significant amount of information if we cast it from double to int. And then while index is greater than 0, while we're still not at the index that we want to be at, we need to keep on traversing through our linked list. Okay? And in this case, we're going to be updating the node itself, because if you look at the return statement, it's returning node.item, right? Which means that the item at the current node is the pivot. And so we have to be updating this node pointer as we go. And then index has to be updated as well.